This video will demonstrate how to evaluate the association among a large number of continuous traits and to search for meaningful correlations in order to find unforeseen patterns. In this demo, I'll select studies in which 262 traits from the morphology, metabolites, and enzyme activity groups were measured on the same tomato population. These studies are located under this folder. The traits list displays all traits, their scales, and groups. Then I'll pick the correlation heat map analysis. Now suppose I want to correlate among all the morphology and metabolites traits. First, I'll take the morphology group of traits. Select them all and put them in the X field. Then I'll take the metabolites group of traits, select them and put them in the Y field. I can change analysis parameters or leave them as default. Then click OK. A heat map is displayed with all morphology traits on the bottom and metabolites on the left. A colored square indicates the correlation between the corresponding traits, such that green is negative correlation, black is zero or no correlation, and red is positive. A mouse point on each square will show the correlation coefficient and the corresponding traits. If I click on a square, the corresponding correlation will be calculated and displayed in a new tab. Here, data points represent genotypes, and they can be viewed and selected from the figure. Going back to the heat map, I can set the heat map subset checkbox. Now when I click on a square on the figure, the system will zoom in on that region and display it as a heat map. The heat map is presented in a new tab. Here again I can click on each square to view the correlation plot and the genotypes that comprise it. The table option is used to display the correlation parameters for the selected traits as a table. Again, I'll select the morphology traits and put them in the X field. Then let's select the enzyme activity group of traits and put all of them in the Y field. I can filter the results based on the correlation parameters and then click OK. Now results are displayed as a table where each row provides the correlation parameters for a particular pair of traits. I can click on a row to display the actual plot. The network option will display all traits as a connected graph. Here I'll select all traits from all groups and then put them in the Y field. I can set the p-value threshold. This will determine what is considered as a significant correlation. Because we have many traits and thus a large number of statistical comparisons, we may want to provide a stringent p-value. Let's make it this number and then click OK. And this is the resulting figure. Each colored circle represents one of the traits. On the top, there's a legend that shows the color for each traits group. A line connecting two nodes or traits represents a significant correlation between them. A red line indicates positive correlation and blue is negative. The layout of the network is determined according to an algorithm that identifies subsets of nodes that are connected to each other more than to other nodes and puts them in close proximity. Indeed, we can see that nodes of the same color, which represent traits from the same group, tend to be located together. Still, we can identify traits that are connected to other traits from different groups. On the bottom, we can download a table that shows the number of positive and negative connections for each trait. This gives us an idea about the importance and centrality of a trait in the network. A click on a node will display a table with the correlation parameters of all traits that this node is connected to. I can then click on the row to see the corresponding plot. Let's go back to the network figure. If I select the univariate distribution checkbox, then a click on any node will display its distribution. And here's the figure. Or if I select the bars checkbox, the click will display all genotypes for this trait. The fit y by x will show replicated data for the selected trait. The dynamic network performs the same analysis and outputs a similar graph like the static image, only that it is displayed dynamically. Let's put again all traits in the y field and set the alpha value to be the same as before. This is how the result looks like. It appears as a Java application created using Welkin from the open source Simul project. Again, each colored node represents a trait, and the color is the traits group. This tool is meant to function like a telescope that virtualizes the network and lets the user understand its global shape and cluster characteristics. I can stop the movement and point on a square to view its trait's name, or drag it to view its connections.